Okay, so I wanted to give you some StatCrunch tips for section 11.2. So I have posted my completed notes for you, so you'll see those on the course homepage. And I included some StatCrunch screenshots in those notes as well. So what I want to do with you on this video is just go through and do kind of a little explanation of what you're seeing there and show you how StatCrunch can be helpful. Now, I'll go ahead and tell you for the Wilcoxon test, StatCrunch is not going to do everything for you. You're still going to have to do a good bit of this yourself by hand. The biggest thing that StatCrunch will help you with is the ranking. And I think that tends to be one of the more tedious parts of these non-parametric tests is making sure that you get the right ranks. And so that's the thing that I tend to use StatCrunch for the most when it comes to these non-parametric tests. All right, so just to kind of make sure that we're clear here, the difference between the assigned rank and the rank sum is whether we're dealing with paired data or independent to separate samples. All right, these are the non-parametric equivalent to those parametric tests that we talked about back in Chapter 8 where we were comparing means. All right, now for the assigned rank test, there's a set of certain values that you need to find that test statistic. And these are all things that you can get StatCrunch to calculate for you, or you can calculate them yourself and then just use StatCrunch to get the ranked value. So in our example here, in our first example, I did this first myself by hand, right? So I just made a difference row, an absolute value, a rank, and assigned rank. So difference, pretty straightforward. Just, take the first value, subtract the second value. Absolute value, we know, just means we're looking at positive only. Rank is where you assign a number based on the order of those entries. The big thing to remember here is that a difference of 0 does not have a rank. So you'll notice I just X that one out. And then for the rest of the absolute values, what I'm doing is ranking them, starting with 1 for the lowest, up to 9 for the highest. And the 0.5 values you see there are when I have values that are the same, values that tie for certain place values. And because of that, again, the rank is really the big thing that I think is the most tedious when I'm trying to find the test statistic here, the thing that's the easiest to make a mistake on, and that is something that StatCrunch can do for you very quickly. So the other option here, and again, this is in your posted notes, so you'll be able to see these screenshots, is to put the paired data in StatCrunch and let it calculate, if nothing else, let it calculate the ranks for me so that I'm not having to figure out what those different values are going to be. All right, so I've got a screenshot for you here, but all I did is I loaded the data into StatCrunch, and then essentially I just like to create that table of values right here in StatCrunch. So remember, what we need is the difference, then the absolute value, then the rank, and the assigned rank. Now, you can compute things in StatCrunch by going to Data and Compute. All right, this will create new columns. So I can go to Expression. Now, yours will look a little bit different from mine when you hit the Build button because I'm on my iPad if you're on a PC, but the steps are pretty much the same. So I'm going to click on Build, and then it will bring up this little window for me where I can specify what I want it to calculate. So remember, the first thing we're doing here is just creating a difference where we take the old design and we subtract the new design. So what I'm going to do is tell it I want it to take the old design. I'm going to click Add Column so it puts it up there at the top in the expression bar. And then I want it to subtract the values in the new design column. So I'm going to add column there. All right, it's just like creating an expression for what I want it to compute based on what I've loaded into StatCrunch. Now, when I hit OK, because that's all I want it to do, if I want to label the column, I can. So like here, I might label these as differences, just so I'll know. And then notice when I hit compute, it creates a new column where it computes the difference between the old design and the new design for each pair of data values. And we can verify that again. I did this one by hand at the beginning. So we could go back and look here. And those differences, 6, 1, 4, -2, 0, that's the same thing that's being computed here. Now, I can just continue to create new expressions. So the next thing I want is the absolute value. So again, I'm going to go to Data and Compute an expression. And then when I go to Build, this time I want to use a particular function. So I'm going to go to my functions over here and say I want the absolute value. I'm going to do Add Function. And then in parentheses, I want it to take the absolute value. And notice because I created a new column, now differences is an option. So I'm going to choose differences, click Add Column. And this is telling it, again, exactly what I want it to do, which is calculate the absolute value of the differences. So I'm going to click OK. I'm going to give it a label that these are the absolute values. And when I hit compute, right, notice what it's doing there. It's just taking the absolute value of each computed difference. Now, the next thing I need is I need ranks. And this is where StatCrunch is very helpful. So I'm going to go to Data. I'm going to go down here where you see it says Rank. It has a built-in function there. And I'm going to tell it that I want to rank the absolute value of the differences. That's all I have to do. Click Compute. And I see my ranks there in the next column. And again, you can look back at where I did these by hand. And you can see that my ranks are matching up. Actually, they're not. Oh, it's that 0. Hang on just a second. The reason that my ranks are not matching up here is because I forgot that values of 0 should not be included. So see right here where it's assigning a rank of 1 to a difference of 0? That should not happen. The 0 difference should be disregarded. So the best thing to do is when you see that you have a 0 difference, just highlight that entire row, go to Data, I think it's Edit. Go to Edit, Rows, and Delete, and just take out that entire pair. Because again, those things should not be included in your rank. All right, so I'm going to do my rank again here. And I'm going to rank those absolute values without the 0 difference. And now what I'm seeing here are ranks that match up to what I got when I did this by hand. So 8, 1, 5.5, 2.5, right? The same thing that you're seeing from where I worked through this by hand. So the moral of the story there is just don't forget, if you have a 0 difference, before you rank, you want to get rid of that completely. All right, so I'm going to take out the one that's incorrect here. I'm going to go to Edit, Column, Delete the first one, which was incorrect. And this is what my table should look like. Now, the last thing you do when you're calculating the test statistic is you assign a negative or a positive to the rank. And you just assign that based on the original sign of the difference. So this I just used to go through and do myself. For example, the first rank is 8. The difference there was a positive 6. So I'm going to keep the signed rank as a positive 8. All right, the second one, the rank is 1. The difference was a positive 1, so I'm going to keep that positive as well. 5.5, the difference was positive 4, so it will stay positive. But then notice the rank of 2.5 corresponded to a negative difference. The difference was -2, so that should become negative. 7's going to stay positive. 9's going to stay positive. The 4, notice, corresponds to a difference of -3. So I'm going to make that negative. And then 2.5 and 5.5. And then remember, what we do to find the test statistic is when we get to the signed rank column, we add up the positive ranks, we add up the negative ranks, and we take the smaller absolute value. So I think you can kind of tell here the negative ranks are going to be the smaller sum because we only have 2 of them and we have a lot more positive ones. So that's why when I was getting my test statistic, I took the negative ranks, which are -4 and -2.5. The sum, of course, -6.5. And I used the absolute value of that for my test statistic. All right. Now, the other thing I want to note for you here is if you go to your stat menu, you're going to notice that you have a non-parametric section of test, and you're going to notice that the signed rank is listed in there. The only thing I will caution you about is this does not always match up to the correct test statistic because technically this test can be done as a left tail or a right tail, depending on if you take the smaller sum or the bigger sum. So for example here, if I click on paired and I tell it I want it to look at old design and new design, and I click compute, notice the Wilcoxon stat, the test statistic it's giving me here is 38.5. And that was actually the bigger sum of my ranks. So in this case, it would have led me in the wrong direction. Now, in some cases, it will turn out correct, but not in all. And that's why I always like to kind of give you a word of caution before you just start using the signed rank and StatCrunch to do all of these problems. So again, what I would encourage you to do is use StatCrunch to help you to get to those ranks, and then you determine from the ranks what that test statistic needs to be. All right, and then, after the test statistic, all of this was explained pretty thoroughly in the Learn the Content video for similar examples. But you've got a specific table that's going to be used. I'll link the table for you on the section page. And then these are always run as a left tail test. You're looking to see if the test statistic, because you're taking the smaller one, is less than or equal to the critical value. All right, now, the other test that you're looking at here, and this is why I gave you some extra time for section 11.2, because you have 2 separate tests that you need to learn. This is called the rank sum test, and this is the one that we use for independent samples. Now, again, StatCrunch is not going to do the whole thing for you, but it can be a big help in terms of getting the ranks, so you don't have to do that on your own. The big thing to remember about the rank sum test is when you get the ranks, you have to make sure that you're ranking all of the data with the 2 samples put together, right? That rank all data. And so if you're going to use StatCrunch for this, when you go to rank, you have to make sure that all your values are in one column together. So what I normally do for the rank sum test is I take my values, I load them into StatCrunch, sorry guys, my iPad is delaying here. There we go. So right here, I just loaded the bachelor's and the associate's degree in column 1 and column 2. But then notice what I did over here in variable 4, and I just copy and pasted. I put all the bachelor's degrees, 54, 50, 63, 76, and then right underneath that, I copied and pasted the associate degrees from 36, 39, 47, and so on. And then I just like to put a second column where I just make myself a note which group it comes from, so that when I start looking at the ranks, I'm going to know which ones are the bachelor's and which ones are the associates. So I'm just putting B's for the bachelor values and A for the associate values. And again, the key thing to remember about rank sum is when you rank, you've got to make sure you have all the data values in the same column. So now that I've copied and pasted everything into variable 4, I'm going to go to data and rank. Choose the column where every value is in there together. And hit compute. So what it's done there is it has ranked the values for the two samples together, starting with 1 at the lowest value, up to, it looks like, 8, 19, 20, 21. 21 is our highest value. So then, at that point, once I have used StatCrunch to get my ranks, I got a little screenshot for you there, then I can just look at which one is the smaller sample. That's the other big thing about rank sum test. Whichever one has the smaller sample size, I want to take the sum of the ranks for that sample, and that's what I use for R when I compute my test statistic. Now, StatCrunch is not going to calculate the mean rank for you, and it's not going to calculate the standard deviation of the ranks. It will not calculate those things correctly. So those are going to require you to use the formula. So this test is still going to be a bit lengthy to get the test statistic, but again, the ranks are where people tend to make the most mistakes, especially if you have values that tie. And so that's where, to me, StatCrunch is the most helpful. Now, one last thing here. Make this a little smaller. Again, when you go to your stat menu, you do have a non-parametric section, and a lot of these tests, or some form of these tests, will be found there. So in this case, if you go to stat and you click on your non-parametric test, the version of this test is actually the one that's called Mann-Whitney. They use a different name for it here. And the big thing about using the Mann-Whitney test is in order for it to calculate your test statistic correctly, you have to make sure that you put the smaller sample in first and the larger sample in second so that it takes the sum of the correct ranks. So the associate degree is the smaller sample. I'll put that first. The bachelor's degree is the larger sample. And then when I hit compute, notice the test statistic here is shown as 58. Now, you're still going to have to standardize that. You're still going to have to make it into a z-score. But that 58 is what I got when I looked at all those ranks and I took the sum of the ranks for the smaller sample. So if you want to take it a step further, you can even use StatCrunch to get the value of R for that test, as long as you're careful about smaller sample first. But then again, you're going to have to get the mean, you're going to have to get the standard deviation in order to standardize that, and then make the decision based on the standard normal distribution. All right, so again, I posted these notes for you, and with each example that I did, I made sure to include some screenshots from StatCrunch. So I encourage you to play around with these. Use StatCrunch to help you, even though it's not going to completely calculate the test statistic for you. And as you do that, please feel free to reach out to me with any questions or any issues that you're coming across.